My name is Caspian, and we are autopcb. We automate printed circuit board PCB design. Circuit boards nowadays are in quite literally almost anything electronic, from the lights to the exit signs and this clicker and many of the startups in this building. The problem is that circuit design is still a very manual process that requires a lot of time from typically an electrical engineer, to draw the schematic, select components, and this ends up being time-consuming, very costly as well. This fundamentally comes down to the fact that a lot of circuits have to be designed specifically for the application where they're being applied to, and it's very difficult to reuse sub-circuits across different applications and circuit boards. AutoPCB solved this problem by automating a lot of the circuit board design process by modularizing sub-circuits that can be reused across different boards. For any electrical engineers in the audience, this may sound familiar because this change already happened with the chip industry maybe 30 years ago with the introduction of Verilog and VHDL for designing chips, for designing FPGAs and digital ASICs. So what we do is we automatically will be able to select components based on a template of a sub-circuit and build a library similar to how software libraries allow software engineers to write software more efficiently. An analogy to explain this is similar to Wix or WordPress for building a website. You can drag and drop you can drag and drop modules on a website to build what you're looking for, and it will write the software, whereas in the past, one would have to hire a software engineer to build a website. In our case, if you need common sub-circuits such as a motor controller, a battery charger, rather than design them from scratch, we can use a template. We can go to the suppliers and find out which components fit the criteria needed for the specific application, place them on the circuit, wire them up, and generate the board. We have a demo. We will skip the demo. But the output of the demo will be the circuit board bill of materials and the typical outputs of that a typical electrical engineer produces. And we've already built a prototype version of the software and had engineers use it, including some who actually had the board manufactured in real life and were able to start using the software and build a board in less than an hour. We've had a range of engineers use it, from hobbyists through professionals, built by us for co-founders who have backgrounds from all of the necessary backgrounds from electrical software engineering and graphics design. And we've had a number of advisors who've helped us as well. In fact, the motive for this project was that I personally had to design circuit boards in the past, becoming familiar with the tedious process, and became motivated to solve this problem among other colleagues. The circuit design software is a very large space, independent from manufacturing, which is a much larger space. And we're targeting primarily the prototype design market because it's more important for prototype circuit boards and low volume boards to design circuit boards more often and on a faster timescale. So currently we're developing the product for mature software users now, adding commercialization features, and we're expecting to complete this fairly soon. And the business follows a standard engineering software business model of subscriptions, but also integrating manufacturing. Another pain point that rapid turnaround projects have is actually ordering PCBs, worrying about suppliers, manufacturing, and integrating that with the software is a recent trend in the market that we also implement for automating the final end of the circuit design process as well, where the board needs to be manufactured and assembled. This type of automation has revolutionized a number of different industries. Wix is famous for making website design available to everyone now. Bubble has changed the app development with no code. We're doing the same thing, but for circuits. And again, for the electrical engineers, similar to what Verilog or VHDL did for ASIC design. We're not the only ones in this market. Fairly recently, there's been a number of startups that have also been tackling this same problem very recently, taking different approaches, some of them taking, for example, a fully programmatic approach, our key advantage is that we stick with the graphical interface, schematic interface that electrical engineers already are familiar with, reducing the barrier of entry, because the largest challenge of any engineering software startup will be to acquire new users. And if you have any questions, feel free to ask.
We have time only for 2 questions.
Yes.
We indeed use a lot of PCB. One of the problem in PCB, I think I can speak loud. So one of the problem we have in PCB is the knowledge, especially if you want to do high speed, the thickness, the material, everything. How do you fill that gap?
Yes, good question. So the goal is to have that information inside of the template module. So if you're doing, say, some circuit that has a number of differential pairs that are routed in a particular way, that information is included in the sub-circuit itself template, in the template of that sub-circuit. Just like a specific application information for a code library is included in the software implementation of that. Question?
Yeah. So with the time that you're saving, that's basically PCB design.
Yes.
Time, that's the value proposition, the time of the development, right?
Correct.
So that should be in spite of or in expense of something that you're losing, right? So
Yes.
I assume that's energy, power consumption, or something like that.
The trade-off in this case is flexibility to novel circuits. So the motive for this project was actually that most sub-circuits inside of a circuit nowadays are really common. Think like motor drivers, wireless interfaces. And the motive is that you can reuse these templates rather than having to create a novel implementation of that sub-circuit. So this is a trade-off between that flexibility. We do have the ability to create custom sub-circuits as well as part of the interface, but that's the trade-off. Great, thank you everyone.
Thanks.